How are you? Welcome to this channel of the Tutors Online. Today we will discuss the petrochemical processes. Various chemical processes are used to convert the primary petrochemicals into secondary or intermediate petrochemicals. Primary petrochemicals are converted into secondary or intermediate petrochemicals. Intermediate petrochemicals or intermediates, petrochemical intermediates. So there are some processes include oxidation, halogenation, nitration, sulfonation. These are the processes which are used to convert primary petrochemicals into secondary or intermediate petrochemicals. Right. Now we discuss the oxidation. Oxidation is the first process of petrochemical oxidation. I discuss it. Oxidation is an important reaction in industrial organic chemistry used at large scale. It is very important reaction, industrial organic chemistry. For small scale production like a few hundred tons year like dye stuff, pharmaceuticals and related compounds. Oxidation methods based on laboratory procedures are utilizing oxidants like KMNO4, it's a potassium, and sodium dichromate. This is also called pinky because its color is pink, and a chlorine Cl2 and sodium perchlorate etc. Large-scale industrial oxidation processes are carried out using air or oxygen O2 as oxidizing medium. So oxidizing medium is the air or O2. Depending upon the medium, oxidation can be classified into three classes. Number one class is the free radical oxidation. Free radical oxidation. Number two is the liquid phase non-free radical oxidation. Liquid phase non-free radical oxidation. And number three is the heterogeneous catalyzed phase oxidation. Heterogeneous catalyzed phase oxidation. Okay, first we discuss the free radical oxidation. Free radical oxidation. Using air or molecular oxygen. Now we discuss the free radical oxidation. Using air or molecular oxygen. Free radical oxidation can be either gas phase oxidation, which occurs during combustion reactions in fuels are liquid phase oxidation, which is the most common in production of petrochemicals. Oxidation of large number of products is carried out by reacting in liquid phase with air or oxygen at moderate temperature, such as oxidation is also called auto-oxidation. Auto-oxidation. Oxidation. Air or oxygen is the cheapest oxidants. These are air and oxygen are the cheapest oxidants. But controlling rate of reaction is very difficult. We discuss the reactions in this article. It can occur at ordinary temperature, but rate of reaction is low, very slow. Therefore, usually carried out at elevated temperature. Mostly catalysts are used to increase rate of reaction for commercial scale processes. Oxidation catalysts may be dissolved or suspended in finely divided form to ensure the contact of air or oxygen with reactants. Such type of oxidation reaction follows free radical mechanism which proceeds through three steps including initiation, propagation and termination. Initiation, number 2, propagation and termination. Reaction is initiated when free radical is formed by cleavage of CH bond in hydrogenation in hydrocarbon substrate. Cleavage occur by abstraction of hydrogen atom by an external species X. Once the free radical is formed, reaction propagates in many ways. The free radical reacts with oxygen to form peroxyl radical. Peroxyl radical abstract hydrogen atom from another substrate. They form hydroperoxide and an other substrate radical. Now discuss the reaction. CH single covalent bond plus X into CC. Okay, plus HX. The substrate further reacts with oxygen to form peroxy radical and finally hydroperoxide. Reaction 2 and 3 are propagation steps and occur in chain. Plus oxygen into single bond O, oxygen. and triple covalent bond carbon, covalent bond oxygen, covalent bond oxygen again, plus triple covalent bond CH into triple bond COOH plus 1 2 3 covalent bond into C. This is the third reaction. This is second, this is third, and last was the first. Okay, the reaction is terminated by reaction of radicals to form neutral molecules. Plus triple covalent bond carbon into triple covalent bond carbon, covalent bond carbon, and covalent bonds. This is the fourth. 6 reactions we discuss. Number 5 reaction, triple covalent bond carbon plus triple covalent bond carbon, oxygen into triple covalent bond carbon OOC. This is the fifth. Now 2 triple covalent bond carbon oxygen into carbon OOC plus oxygen. Sixth reaction. The common example of large-scale free radical oxidation is the oxidation of cumene, which is important starting material for the production of phenol and acetone. Usually, cumene is not available but produced from propylene. Cumene is not usually available but produced from propylene. And benzene. The process involves the formation of cumene by reaction of benzene and propylene in the presence of acetic catalyst. Cumene is then oxidized by molecular oxygen at 110 to 115 centigrade to form cumene hydroperoxide, which is further dehydrated to phenol and acetone. Now discuss its reaction. Benzene plus CH3 C double bond CH2 in the presence of AlCl3 or H3PO4 CH3 2 CH and under is the benzene. So this is the reaction. Further we'll discuss note it. If you want to note it, then note it. You can also take the screenshot of these all reactions. So now we discuss the next. If we open the chains, CH, CH3, CH3 in the presence of oxygen 110 to 115 centigrade temperature, benzene C CH3 double bond H CH3, and further in the presence of dilute H2SO4 sulfuric acid. H2SO4 70 to 80 centigrade temperature gives phenol OH. Phenol plus acetone CH3 2CO. This is the acetone. CH3 2CO. Phenol and acetone. Now we consider a diagram oxidation vessel. First of all, this is the reaction vessel. What is this? Reaction vessel. Reaction vessel. In this reaction vessel, 400 atm pressure, 220 centigrade temperature, and AlCl3 is the catalyst. We give it benzene and propene. It gives us further, it becomes the cumene, and in the next oxidation vessel, temperature is 110 to 1150 centigrade, and we add oxygen in it. This is the oxidation vessel. This is the, we are discussing the flow sheet diagram representing the oxidation of cumene. Now, next reaction vessel, we add dilute sulfuric acid, dilute H2SO4 in this reaction vessel. Now this further go to the distillation unit. Distillation unit. Phenol, and number 2 is the acetone. Unsaturated cumene go to the oxidation vessel. Unsaturated, unreacted cumene go to the oxidation vessel. This is the oxidation vessel. Cumene. So it is the flow sheet diagram representing the oxidation of cumene. Now we will discuss the second thing, liquid phase non-free radical oxidation. Number 2 is the liquid phase non-free radical oxidation. Liquid phase non-free radical oxidation is carried out by homogeneous catalyst in solution form. Homogeneous catalyst in solution form in the presence of air or oxygen. During the process, the catalyst form complex with the reactant. Which leads tooth formation of oxidation products. Common example of such type oxidation is Waker chimney process. Example is the Waker chimney process. Waker chimney process and for the Waker chimney process for the production of acetaldehyde from ethylene. Ethylene go to acetaldehyde. The reaction was accidentally discovered in 1950 when production of ethylene oxide was tried from ethylene in the presence of PD chloride impregnated on charcoal and led to formation of acetaldehyde in a single stage. Waker chimney process for the production of acetaldehyde, excess of ethylene and oxygen is passed over aqueous solution of PdCl2 plus copper chloride at 60 to 70 centigrade temperature and 3 atm pressure. From the product, stream acetaldehyde is removed by scrubbing with water and excess of ethylene is recycled. Acetaldehyde is removed from aqueous solution of distillation. The two-stage process involving the regeneration of catalyst by air. Now we discuss the reaction. First, C2H4 reversible reaction in the presence of PdCl4 minus 2 minus Cl, chlorine is removed, it becomes CH2 double bond CH2 to PdCl3, bracket close, and then again reversible reaction in the presence of water minus chloride into CH2 double bond CH2 PdCl2 OH2. So this is the reaction 100% correct. And again reversible reaction we discuss here on next page. You can see our previous things also. Now reversible reaction, one hydrogen ion is removed from this, again reversible reaction on next PTO. CH2 double bond CH2 PdCl2 OH minus into HOCH2 CH2 PdCl2 minus, again reversible reaction CHOH double bond CH2 PdHCl2 H2C CHOH PdCl2 bracket close H2O into CH2 CH OH OH2 plus PdCl2 minus 2, and it again go to the in the minus H2O, and minus hydrogen ion gives CH2CHO. This is the reaction. Liquid phase non-free radical oxidation. Now we discuss the third, heterogeneous catalyzed gas phase oxidation. Number 3 is the heterogeneous catalyzed gas phase oxidation. Such type oxidation occurs in the presence of heterogeneous phase solid catalysts. Heterogeneous phase solid catalyst. The mechanism of the process is not fully understood. Catalysts mostly used are metals and metal oxides. Generally, oxygen and reactants adsorbed on the catalyst surface, where the chemical interaction occurs and leads to product formation. Major flaw in engineering of heterogeneous catalyzed gas phase oxidation is a high exothermic nature of reaction. Removal of heat generated from catalyst bed is a main problem. Removal of heat generated from catalyst bed is the main problem. What is the main problem? Removal of heat generated from catalyst bed is the main problem. Failure of heat removal leads to overheating and loss of yield. Therefore, the tubular or fluidized beds reactors are used. Example of heterogeneous catalyzed gas phase reaction is oxidation of ethylene by air or oxygen to ethylene oxide, or silver supported on aluminium catalyst. The contact time is about 1 to 4 seconds and yield is 70 to 75%. Reaction is this: H2C double bond CH2 into oxygen and silver, 250 to 330 centigrade temperature. It gives the H2C CH2 CC. So these are the heterogeneous catalyzed gas phase reaction. Gas phase reaction. Now, if you allow me, I can discuss the halogenation. Full detail, but we should discuss it in the next video. But if you say, I can discuss it. So if you need tutor online for any class, you can contact us, And if you don't subscribe our channel, then please subscribe and press the bell icon. Never miss any update. Thank you very much. Now we discuss the halogenation. Halogenation is chemical reaction that involves addition of halogen atom to a compound. Halogenation carried out for two reasons in commercial operations: for use in subsequent synthetic operation, and number two is the obtain products with desirable technological properties. And product of halogenation are of great commercial use, that are the solvents, dye stuff, drugs, anesthetics, insecticides, herbicides. Out of halogen, chlorine is the cheapest and mostly used. Bromine and iodine are less frequently sometimes used respectively. Chlorine is mostly used. Halogenation is commonly carried out using different routes such as free radical halogenation, addition of halogens to unsaturated compounds such as alkenes and alkynes, and electrophilic substitution reactions of aromatics, fluorination, chlorination, and others. First we discuss the fluorination. We can discuss halogenation. Now we will discuss the fluorination. Fluorination of organic compounds, whether they are saturated and unsaturated, is alike. They react readily or explosively with fluorine to give fluorinated products. Fluorination of organic compounds whether they are saturated and unsaturated, is alike. They react readily or explosively with fluorine to give fluorinated product. They react readily, fastly, or explosively with fluorine to give fluorinated products. This process requires highly specialized conditions. This process required highly specialized conditions. Fluorination of organic compounds may also be carried out electrochemically, wherein reactions occur at anode using hydrogen fluoride as the source of fluorine. Please note, you can listen it again and again. If I write on the page, then video can be several hours. So I tell you with voice, you can note down on your notebook. This is very important topics I am discussing follow we were discussing fluorination, wherein reactions occur at an anode using hydrogen fluoride as source of fluorine. Now discuss the chlorination. Chlorination of organic compounds is generally highly exothermic. Highly exothermic. Saturated hydrocarbons react with chlorine in the presence of UV light to initiate homolysis. Various unsaturated compounds react directly with chlorine without UV light. Now discuss the bromination. Bromination is more selective than chlorination because the reaction is less exothermic. Fluorination is done. Chlorination is done. Bromination. Now we discuss the bromination. Bromination is more selective than chlorination because the reaction is less exothermic. Most commonly, bromination is conducted by the addition of bromine to alkenes. Bromination of saturated compounds of saturated hydrocarbons and aromatic substrates is common in nature, giving rise to a host of organobromine compounds. Iodine is the least reactive halogen and is reluctant to react with most organic compounds. The addition of iodine to alkenes is the basis of analytical method called iodine number, a measure of degree of unsaturation. Iodine number. Variety of halogenation products are produced and used as important products or industrial raw materials. Chloromethanes are important industrial solvents which are produced in gas phase reaction of chlorine and CH4 in the presence of UV light or thermally at 250 centigrade. Now we discuss the reactions. CH4 plus chlorine plus chlorine minus HCl, it gives CH3Cl, it gives plus chloride minus HCl, it gives CH2Cl2, and again add plus chlorine and minus HCl, it gives CHCl3. Add the chlorine minus HCl, it gives CCl4. Vinyl chloride is important raw material for production of polyvinyl chloride on large scale. It is synthesized by chlorination of acetylene with HCl in the presence of HgCl2. Catalyst at 100 to 180 centigrade temperature. It is also produced on large scale from ethylene by direct chlorination with chlorine and oxychlorination process, which involve the oxidation of HCl in the presence of ethylene using CuCl2 catalyst, followed by pyrolysis at 500 centigrade. Now we discuss the reaction. CH triple bond CH plus HCl in the presence of HgCl2 or carbon at 110 to 180 centigrade. It gives CH2C double bond CHCl. Now discuss the next reaction. C2H4 plus HCl in the presence of CuCl2 oxygen 250 to 350 centigrade. Cl H2C double bond CH2Cl plus water. Cl H2C double bond CH2Cl in the presence of 500 centigrade temperature, it gives H2C double bond CHCl. There are many more important halogenation products used for different purposes, such as hexachlorobenzene, chloropropene, DDT, chlordane, 2,4-D, MCPA, bromochloroethane, ethylene, dibromide, and halothane, extra. Now we discuss the nitration. Nitration is very important. Nitration. Nitration is oldest process used for preparation of industrial chemicals. Most commonly used nitration is aromatic electrophilic substitution reaction, in which NO2 group substitute a hydrogen NO2 substitute a hydrogen atom in an aromatic ring. It is carried out by reacting the organic aromatic compound with nitrating mixture consists of HNO3 and H2SO4 in which the NO2 plus group produces as a result of acid reaction replace the hydrogen atom in organic compound. Nitrobenzene is produced similarly, which is used in the production of aniline. Benzene is reacted with a nitrating mixture containing 60 to 53 centigrade H2SO4 and 32 to 39% HNO3 and 8% water at 50 centigrade. The reaction is the following. Here is the benzene plus NO2 plus, it gives intermediate. Here is a NO2 and here is a H. It gives a final product nitrobenzene. NO2. Nitration of toluene is carried out to produce mono, di and trinitrotoluene TNT. TNT, trinitrotoluene, is used as the military explosive. Various mono and di nitrotoluene are used in the manufacture of toluenes and dyestuff intermediates. Okay, this was the nitration. Now we discuss the sulfonation. Sulfonation. It is also an important reaction process of the petrochemicals. It is the last. Sulfonation of organic compounds is generally carried out by reaction with oleum or sulfur trioxide, in which sulfonic acid group is added to molecule. Sulfur trioxide. In this process, SO3 group replace the hydrogen atom the compounds by mechanism of aromatic electrophilic substitution reaction. Sulfonation of organic compounds is either carried out to change the properties of organic compounds such as polarity, solubility, or to produce an intermediate product in which the sulfonate can be further reacted to get the desired product. Benzene sulfonic acid can be produced as intermediate for manufacture of phenol. It is formed by reaction on benzene with excess of 100% H2SO4 at 70 to 80 centigrade. Disulfonation of benzene followed by hydrolysis leads to formation of resorcinol. Now we discuss the reaction. Reaction is very important. So consider it carefully. Here is one benzene. Benzene, 6 carbon in the presence of H2SO4 sulfuric acid, and this gives a SO3H in the presence of ONA and ONA, it gives a further benzene can also write as OH and OH. Okay, consider this reaction very carefully. Chlorosulfonation of toluene is carried out to produce an intermediate for synthesis of saccharin. Chlorosulfonation of toluene is carried out to produce an intermediate for synthesis of saccharin.